Hello friends, welcome back to the next session on operations planning, scheduling and control. Now let's begin with our learning. In this particular module, we'll be understanding and dealing with a case study. A case study related with flexible job shop scheduling with operators in aeronautical manufacturing industry. The learning objectives. At the end of this session, the learners will be able to understand what do we mean by job shop, flow shop and servicing sequencing, and along with we'll be also undertaking a case study on job shop, flow shop and service sequencing. Now let's begin with our learning. The overview of this particular case. This particular chapter or this session will be divided into various types. That is, number one, we'll be understanding the introduction or overview of the case. Then we'll be understanding what does the case study with respect to the flexible job shop scheduling with operations in aeronautical manufacturing is there into existence, and how those activities as to the job shop, flow shop and service sequencing is been applied and taken into account in the service industry or the aeronautical industry, manufacturing industry. Now let's understand the background of the case study. This particular case study examines about what are the various activities that have been undertaken in an aeronautical industry, and it also deals with the various real life case studies and examples as to how the real or the aerospace or aeronautical industry is performing their respective activities. In an aerospace industry, several number of activities or operations are needed to be taken into account. And those particular activities are of a frequent stage, that is, a process or an assembly line is into existence, and several number of job operations are being conducted on the assembly line. In this particular case, now when several number of assembly lines are been into existence, several multiple products are also employed in order to conduct the various different activities. And hence, various number of machines, various number of laborers are also employed for conducting or completion of those activities. Simultaneously, one has to understand that when several number of activities are needed to be undertaken, those particular activities should be either conducted on the job shop, job flow or service sequencing. And out of those particular activities, job shop scheduling is essentially important. So when we schedule a particular activity, it has to be seen and monitored that that particular activity gets completed within the specified time period. All the activities which have been designated, that is the input of material, the processing of raw material and delivery of the finished goods and services should be completed within a specified time. And for those particular consideration, a minimum time should always be specified and a maximum output time for a product should also be specified. When in an assembly line, when all the activities are being conducted in a certain sequence, every activity is important of its own. So one has to understand and see that what are the various assembly line activities that have been taken into account and how those assembly activities are being conducted in a very effective way. For this particular consideration, every activity or a particular transaction or a particular operational activity that has been undertaken on the assembly line is associated with a certain amount of cost. And those particular cost expenditure is needed to be incurred in the organization. And hence, when we say that a cost is been associated in an airframe industry, at that particular stage, the previous studies have shown that there must be an effective production planning model which needs to be into existence. And with a proper production planning model into existence, the activities that can be conducted in an airframe industry or an airline industry can be conducted in a very effective and a smooth way. So for this particular consideration, one has to understand as to what are the various activities that have been conducted in a business organizations and how those activities needs to be scheduled. In addition to this, the program's output refers to a set of schedules, which comprises of various combinations of number of operators and intermediate stocks, allowing for the improved decision making. So, in order to improve the decision making in an airframe industry, one has to see that what number of stocks are available with them, how the quantity or amount of stock needs to be moved from one location to another location, one process to another process, and how those activity needs to be coordinated. And hence, for those consideration, the industry needs to be of a perfect stage wherein all the activities are being conducted in a proper sequence. Now, in order to handle this particular problem, a mixed integer, that is a linear programming model, needs to be implemented, and which will help or which will be beneficial to find out how the activities can be conducted in a better way, and the real-time examples or the experiments as to the aerospace industry can be applied. So for this consideration, a linear programming model was being adopted by a firm, and accordingly it was being seen that how the activities of job shop, flow shop, and service sequencing can be applied in this particular industry. Now, here, when we are calculating the activities of job shop, flow shop, and service sequencing, one has to see that both the perspective, that is the quality as well as the calculation time for or the movement of time for a certain product or commodity or goods is also been calculated in a very effective way, and it also surpasses the industrial methods. The industrial methods as to what should be the runtime error, what should be the wastage or salvage, what should be the amount of goods that needs to be produced, how the delivery time should be completed, and accordingly, everything activity should be completed within a specified time period. And hence, the various studies have also shown that scheduling a particular activity and completing the activity in the scheduled task is of utmost importance. And this particular case study focuses on those particular concepts of the application of knowledge for a better development of scheduling plan. Hence, however, reducing the number of operators and intermediate stock could have bigger impact on could have a bigger impact on the labor-intensive businesses, which allows for faster and more accurate decision making. So, the labor-intensive techniques as to availability of labor, conduction of the number of working hours, and how the activity is being completed, everything plays an important role with respect to the labor-intensive factors. These particular factors impact the decision making process, because whenever a particular decision is being undertaken, it has to be seen that that particular decision is being implemented in the organization and it gets utilized in an effective and a better way. And hence, for those particular consideration, the decision making in the aerospace industry should be very quick and effective. Now let's understand what is the case all about. In an aircraft manufacturer's industry, everything gets affected by its activity that have been conducted according to the product. And accordingly, depending on the product flexibility, complexity, and so on, a reduction in the time to market and production leads to time and cost savings or a cost expenditure. So if the number of series of activities are more and the time required is also more for a certain concern, then accordingly, the time that has been consumed, the cost that has been expended, everything goes on increasing. And if the activities have been completed in a very effective way within a very short period or span of time, then accordingly the company can save additionally the cost factor also and the time factor also. And hence, in an aircraft manufacturing industry, these particular factors matter a lot. Now, in the upcoming fourth industrial revolution, which is taking place, it triggered the certain consideration as to IoT, that is the concept of Internet of Things, in which more preference is given or the priority is been given for the technology along with the qualitative delivery of services. And when in a particular manufacturing environment, one has to understand and see that how those particular industry activities can be performed in a better way, and accordingly the industry has named this particular activity as 4.0. And hence the industrial environment should be, or the manufacturing environment should be quite effective, and it should have a long lasting impact on the manufacturing as well as on the services sector. So this particular case study as to aircraft manufacturers focuses on how those particular activities needs to be coordinated in terms of the industrial revolution which is into existence, and a long run perspectives can be implied in the organization. Simultaneously, a wide range of product lifecycle management, that is PLM, is also into existence. Now, in case of an aircraft or airspace industry, we have to see that what industry or what components are being employed, and accordingly, who is been conducting those particular activities. These particular activities can be conducted in a highly industrialized or highly advanced digitalized process concern, or according to the traditional mode of business that is being undertaken in a business organization. And hence, the product lifecycle management theory or the method focuses on using of various industrial tools and techniques, and how those particular tools and techniques can help in better preparation or manufacturing of operational resources in the long run as well as in the short run. Now let's understand what are the 4 airframes that have been produced on the product line. The case study of this particular aircraft industry focuses on the 4 airframes which has been produced in the manufacturing line. That is, the firm initially has to take the contracts of manufacturing and then install the aircraft. That is, the 4 components that was been applicable at this particular stage for a study was FCALH, FCARH, FCBLH, and FCBRH. wherein AB and AB are the various components, and accordingly the aircraft maintenance of LH and RH a certain denomination as to which product you are referring for. And this was the terminology that was being used in the case study. And hence, those particular 4 product line was been into existence, and accordingly, the contract to manufacture and installation of aircraft was been given. Now, this particular diagram or this slide focuses on what is the number of activities or the time taken for completion of each every activity. The respective either the squares or the circles or the rectangles shows you the movement or direction in which the goods and services or the air in the aircraft industry is been moving. This case study being focusing on the job shop scheduling activity, that is an operational activity with respect to the job shop, shows the flow of activity in a particular organization. That is from one to, that is here in this case, you can see initially the activity has been initiated at 1, then it moves to activity number 2, wherein all the processes or all the activities have been undertaken. Then it again moves to a certain consideration, that is the parameter of the circle number 4 and circle number 3. And here certain amount of processes have been undertaken, and then the job shop or the flow shop activity of second sequence, that is number 2 triangle, is into existence. Further, the fifth activity that is been now in this case in the previous slide, you can see here is ALH, ARH, BLH and BRH. So ALH, ALM, BLH and so on. So all these activities are being performed at the respective squares level. So here in this case, when we say that ALL, that is all the activities with respect to the 4 components, that is maybe it FCAH, FCARH, FCBLH or FCBRH, all the activities have been conducted at this particular level. But here in the scenario of fifth composition, the activities differs, and accordingly all the activities have been conducted in a different way. Again, in combination of together, the flexible job shop scheduling or the flow shop scheduling, the activity again gets divided into RH, RH, LH and DH, and accordingly it moves from second triangle, that is second position of the second assembly line, to the third assembly line. And here in this case, the movement or the goods and services are applicable at circle number 6. After completion of all these particular activities, again you can see that there is an additional job shop or flow shop activity with respect to triangle number 4. And accordingly, here in this case, the circle number 7 is applicable, and hence the activity gets circulated. Again, when all the processes as to ALL is been, that is all activities have been completed at this stage, then again the activity or the assembly line moves to all the completion of finished goods, and accordingly the circle number 8 focuses on how the activity is been completed, and this is the end point or completion time of a certain activity. So this was the job shop activity or the flow shop activity which an organization with respect to sequencing was been undertaking. Now let's look at the second diagram on the right hand side, which is applicable or which you can see. So this particular activity or the curve shows the higher taken time for completion or conduction of a certain activity. The green line or the green dotted line shows about what is the number of operators that is into existence and what time is been taken. So time takes, that is 6 days. So accordingly, how many number of days have been taken for completion of a certain activity. So in this case, how, that is the number of days you can see here at this stage is 6 days can be undertaken. For a red color line, it takes around 5 days, and for a blue color line, it takes around 4 days for completion of a certain activity. So number of operators, the greater the number of operators are being applied, accordingly the average number of time or the time taken for completion of a certain activity also is reducing. That is where the number of operators was 15, and accordingly the days that were taken was 6. The number of operators increased to either 18 or 20. Then accordingly the time taken is 5 days, and accordingly if the number of operators are increased between 25 to 30, then accordingly the time taken for completion of certain activity is 4 days. So accordingly the time gets reduced with the number of operators that have been employed or deployed in an operation firm or a manufacturing firm. Now let's understand at this particular stage what are the problems that have been associated. The problems that have been associated with this particular case study is the separate processes that have been undertaken. So there are 5 buffers that exist in this particular situation, and the triangles that appear in the assembly line in figure 1 indicate the buffer. So in the previous stage, the triangles, that is 5 stages of buffers we can see, that is number 1, 2, 3, 4 and 5. So 5 are the triangles which are into existence, and those particular triangles are the buffers that exist in a certain organization. So between every separate process that is being undertaken, that is been moving from one activity to another activity, that is number 1 to 2, between 2 to 3 and 4, and so on. At every stage there is a buffer line, and this particular buffer line differs from activity to activity, input to input, that is there in the organization. And although additional buffer areas might be allocated, we try to avoid doing so for safety reasons and to avoid causing harm. So here in this case, how many number of buffers should be employed or deployed in a particular organization or a particular assembly line needs to be identified, and accordingly the series of activities should be implemented or should be undertaken. Now let's understand what are the various possibilities with respect to the deployment or usage of activities in a certain organization. So in the assembly line, there are two sorts of operator profiles. One, the production, and the other is non-production. So when the first operators are higher, they are being paid very immediately. So in the examination or in the particular example, we can see that whenever there is a buffer line which is into existence, wherever that is a production activity, that is the first operator is being employed, the payment for those particular considerations are being done very immediately. And during the scheduling process of horizons, the number of production operators each shift remains constant. So for every time cycle time of a certain activity, the time that has been allocated or the period that has been scheduled is always remaining constant. And hence scheduling of horizon is at every stage is quite simple, it is quite stable, and it does not changes according to the changes in the life cycle or the product activity that has been undertaken. As a result of this, the cost of production of operator is proportional to the maximum number of operators used per shift. So whatever number of activities that have been undertaken per shift, those particular activities are changing as per the production operator and also changing as per the non-production operator. In case of the non-production operator, the profiles are very compensated for the hours they actually work. So depending on what is the productivity, depending on how many number of working hours have been undertaken, the profile of the non-production operators differs, and hence the compensation that is also being paid for the non-production operators is also quite different than the production operators. But in case of the production operators, the first operators are the first operators who have been hired, and they are also the one who have been paid very immediately. The next last point, that is a possibility that has been associated, their price is determined by the basis of workload of a process which they are been assigned. So based on the workload which has been assigned, whether activity has been conducted of either RH or LH or all category, the payment or the workload or a composition of activities of the product line is been assessed and identified, and accordingly the payment or the price is been determined for a certain product or for a certain activity. And hence the determination on the basis of workload is essentially important, and only on those particular basis the activity or the series of activities are being conducted in a certain organization. Now, this particular diagram or the table is been taken from the case study to give you a brief overview of understanding of what is the calculations or what are the various observations based on the implementation of a certain decision. So certain instances as to the buffer line, that is the buffer stock of either 4 by 4, 5 by 5, 6 by 6, 4 by 6 or 6 by 4 is into existence. What is the time horizon that has been utilized or occupied for completion of a certain activity? That is, in case of 4 by 4 buffer zones, it was 4. In case of 5 by 5, it was 5. In case of 6 by 6, it was 6. In case of 4 by 6, it was 12. And in case of 6 by 4, again, it was 12. And what are the variations in the quantity? So the standard quantity, that is 5084, and the increased variation is 5122. The standard variation in terms of 5 by 5 is 6348, and in terms of actual consideration is 6394. The standard variation in terms of 6 by 6 is 7612, and the actual variations in this particular consideration is 7666. The standard variations in terms of 4 by 6 is 15196, and accordingly the actual composition or the calculation is 15298. So it's an increasing scenario. And lastly, in case of a buffer zone with respect to 6 by 4, the standard variations was 15196, and actual variation that was being observed is 15298. Now, the next row or the column focuses on what are the various constraints or how many number of constraints can be undertaken in those particular considerations. The next column focuses on the solving time that has been utilized or occupied for solving a particular problem that may arise for a specific cycle. For the 4 by 4, it is 16 seconds. For the 5 by 5, it is 39 seconds. For the 6 by 6, it is 400 seconds. For the 4 by 6, it is 7537 seconds, and for the 6x4 is 9178 seconds. So accordingly, as the number of buffer zones increases, so accordingly the solving time of a certain product or a certain activity or the operational line in the assembly line also increases simultaneously. So minimum or less number of buffer zones, the less number of time is been utilized or it is been consumed, and less number of variations can be observed in the organization. And accordingly, there are less number of time horizon days also that have been occupied. The number of operators. Now here, when the buffer zones are 4x4, the number of operators are increased, and accordingly, the time horizon is also being saved, wherein the number of operators are 27 and the time horizon is 4. In case of a certain constitution wherein buffer zone is 6x6, the number of operators are 16 and the time horizon is also occupied, that is number of days that is completed is 6. So now let's understand the last example or the last column with respect to average buffer zone in the plant. So what is the calculation of average buffer in the plant, which shows about what is the objective function that has been fulfilled. So 14.94 for a 4x4, 9.85 for 5x5, for 6x6 it is 4.71, it is 6.73 for 4x6, and for 6x4 it is 7.60. And hence there are difference in variations or difference in calculations for each and every component or a possibility. Now, based on the formula or based on the calculations, what are the various terminologies that have been used in terms of this particular case study? The factor as to E signifies or clarifies the set of elements E that are being produced. The capital P provides about set of processes, that is P, that must be performed. The M states about the set of machines, that is M. So how many number of machines have been employed, what are the number of activities or the processes that have been undertaken, and how many elements that have been produced. The capital T focuses on set of types T of operators. So what type of operators are performing the specific job or a certain activity. The composition as to T raised to P tells about the subset of types T that belong to a production category. The composition as to T raised to NP provides about subsets of types T that belong to a non-production category. And then further, the S denotes the set of slots which have been created in a certain organization for passing of product into the assembly line. The composition as to CY focuses on set of cycles, that is CY, in which the time is been divided. That is, how many number of cycles or how many number of work activities are been conducted in a specified time period. The CYE states about subset of cycles CY of each and every single individual element. And lastly, the composition as to S is to E CY tells about the subset of slot S that belong to each cycle CY of the element E. So in this way, the various studies with respect to the aerospace industry was being undertaken, and accordingly it considers about the machines, the processes, the elements, the set of types, the subset types, the cycle, the operation cycle, and the subsets of those particular cycles in which each and every activity is been divided into those slots. So that was the understanding of the various possibilities. Now let's understand what are the various options of variable available with this particular case study. Number one, the options of variables that are available with this case study is minimizing the number of operators. So whatever number of buffer zones or whatever number of operators are being employed, the case or the aerospace industry should try to see that the number of operators should be reduced. Earlier, it was around 7 to 8 operators. Several number of activities was being conducted, and those particular several number of activities or the operator needs to be minimized. Minimizing the average size of the buffer in the plant. So whatever buffer that has been created in the plant as to 4x4 or 4x6 or 5x5 or 6x4 or 6x6, all those average size of the buffer in the plant should try to be reduced, and accordingly the average productivity or the variations in those particular product also needs to be minimized and needs to be reduced. So accordingly, the number of time taken in terms of days also gets reduced. In case of 4x4, it was 4 days. In case of 5x5, it was 5 days. In case of 6x6, it was 6 days, and so on. So accordingly, the number of working days or the average days for a completion of period also increases simultaneously. Now let's understand what are the various computation results on the basis of implementation of various concerns as to how the preliminary activities are been changing. So as per the calculations, this particular part shows about the preliminary testing, the cutting activity, the workbench assembly 1, the workbench assembly 2, the equipping, the furnishing, the soft cutting, the final testing, and lastly the final operations. And the activity as to FCALH, FCARH, FCBLH and FCBRH is being shown in this particular diagram, wherein different variations as to the values and quantities can be seen in each and every column or the row that you are seeing. That is, in the column of preliminary testing, the valuation is 4, 4, 8, and 8, and so on. And lastly, the final operational activity, that is with respect to FCALH is 12, FCARH is 12, FCBLH is 12, and again FCBRH is 12, wherein the final test that is being conducted is also 8, similar for all the activities that have been performed either with respect to the buffer zone or with respect to the inventory or with respect to the movement of assembly line and the goods and services in a certain organization. And hence, those particular activities needs to be performed. So in this case, a quick revision of what are the output of these particular stages is, you can see with the increase in the number of operators, the time reduction or the time completion activity or the time we are taken for a completion of a certain activity also reduces simultaneously. That is, time when the number of operators are reduced or if they have been increased to more than 25 to between to 17, then accordingly the time taken is 4 days. If it is been reduced, that is from 15 to around 10, then accordingly the time taken is 5 days. If it gets again reduced from the quantity of 18 to 10 or 12, then accordingly the time taken is 6 days. So as the number of operators reduces, the time taken also increases, and as the number of operators increases, the time taken decreases. So now let us understand what are the outcomes of this particular case study. So the implementation of MILP model for the scheduling of a cyclic flexible job shop problem with operators is described in this particular research. So the research paper or the case study focuses on how do we implement a MILP model and what are the various scheduling activities that can be undertaken in an aerospace industry. Up to 11 machines, 45 separate processes, and 30 operators, that is problem was being solved. So for an effective problem solving situation, maximum number of machines, maximum number of separate processes should be undertaken, and accordingly more number of operators should be employed simultaneously, which will help to reduce the problem at an early stage and get the number of buffer zones reduced, and accordingly get the work completed in a very specific time period at an early stage. So these were the conclusions with respect to the model, that is MILP model, that was being implemented in a aerospace industry. This model also tested and used the real life instances and scheduling horizons, which were ranging from 12 days to 14 to 4 working days. So accordingly, in our case study in a diagrammatic position, we have seen the examples of 4, 5, and 6 number of working days. But this particular model has in actual tested the 12 working days situation, in which how various commodities or goods can be employed, and how the number of processes or the number of activities or the operators and the machines can be either increased or they can be decreased. So based on those particular simulation, those activities were performed. This issue has been addressed in the previous studies to the author's knowledge. So several knowledge has been added to the author's study, and it has undertaken about how those activities can be completed in a specified time period. Furthermore, the additional research that was being undertaken in terms of the research undertaking, it also implies that how the aeronautical industry can implement their human resource activities, and more number of people can be employed or focused on in the organization. So for a process to be in an effective stage and to bring in the competitive situation in the particular market, those particular activities should be controlled, it should be reduced, and accordingly the human resource employment or deployment should also be controlled in a very effective way. The cost of human resource is also immediately required to be reduced whenever the number of workers on a manufacturing line is also reduced simultaneously. And lastly, the manager's participation in order to increase the intermediate stock, in order to see that all the activities are being conducted in an effective way, is essentially required. Now let's understand what are the various outcomes of this particular case study. The particular outcomes of this particular case study focuses on the usage of real-world data to address the real-world problem and use a dual strategy as to what experiments can be employed. The challenges that have been exclusively related to aerospace industry, it focuses on how various labor-intensive industries and shipbuilding industries or aerospace industry can apply this particular concept as to the application of MILP model and how it can be benefit in the long run or the short run situation. This particular case study also deals with the simultaneous assignments of the various machines, the various time slots, and the operators to a certain job. And the findings of this particular case study are also beneficial for the research purpose. Now let's summarize what we have learned in this particular session. In this particular session, the learners or we have understood what do we mean by job shop, flow shop, and service sequencing. And along with this, along with the concepts of the job shop, flow shop, and servicing sequencing, we have also undertaken a case study with respect to the job shop scheduling activities in an operations activity in an aeronautical manufacturing industry. I hope you must have enjoyed the learning at this particular stage. Thank you for your patience listening. Thank you.